Okay, so you're here because, let's be honest, you've heard about all this layer 2 stuff happening on Ethereum,
Yeah,
and you want to figure out what is going on with these changes coming up.
right.
Specifically this thing called blob space
Yeah.
and the EIP-4844 upgrade.
Yeah, the blob space upgrade you can think of it as,
Yeah.
or Proto-Danksharding as the real techie term is.
Right. But let's forget the jargon for a second and just talk like what is actually in it for like you, the listener of this show.
Yeah, why should you care about blobs?
Yeah.
And the answer is simple. Hopefully cheaper transactions on those layer twos that
Right.
you're hearing about.
Exactly. And we're going to get into like how that actually happens.
Yep. So this deep dive is going to be your quick route to grasping what could potentially be a huge leap forward for Ethereum scaling.
Yeah.
We're going to cover why this shift is occurring, what's happening under the hood with this blob space,
Yeah.
and crucially, how it's designed to bring down the cost of using rollups.
For everyone.
For everyone, for the average user, for me, for you.
That's right.
This could be really like as foundational as when block space itself was introduced on Ethereum.
I think that's right. Yeah.
So Ethereum's been trying to scale for a while now.
Yeah.
And the current strategy is this thing that they're calling a rollup-centric roadmap.
That's right.
But the initial plan for scaling Ethereum looked quite different.
It did.
Yeah.
The initial ambition was something called execution sharding.
Right.
So you can picture splitting the main Ethereum blockchain into numerous smaller parallel blockchains operating at the same time.
So like multiplying the throughput just by having more chains going?
That's the idea. The idea is that more chains means more processing power.
Yeah. And so what were the hurdles that stopped that approach from happening?
Yeah, so while the idea of sort of parallel processing was appealing
Right.
For speed, ensuring the security and consistency across all those independent chains.
Right. Proved to be a massive challenge.
Yeah.
So if you have all these different chains, all sort of validating transactions separately, you have to coordinate all the validators and make sure that no single shard can be compromised or taken over.
Right.
And that created a lot of complexity. And it became clear that maintaining a high level of security with that many moving parts would be incredibly difficult.
So it's like herding cats, basically.
Yeah.
Too many chains, too much to coordinate.
Yeah, and security is paramount.
Yeah. So they realized that was maybe too difficult, and then they shifted focus to roll-ups.
Precisely. So the complexity of securely implementing that execution sharding led the Ethereum community to prioritize this roll-up-centric roadmap.
Right.
And the core principle here is that layer 2 scaling solutions.
Yeah.
So your optimisms, your arbitrums, your ZK syncs, these roll-ups, as we call them, they take on the bulk of actually processing transactions off of the main Ethereum chain.
And that's what like I as a user have been doing.
Exactly.
Using those layer 2s to like avoid those hefty mainnet gas fees.
That's right.
So if those roll-ups are doing all the work, how does the main Ethereum chain still provide the security for it all?
That's the crucial connection.
Yeah.
So these roll-ups inherit the strong security of the main Ethereum layer 1 by posting data about all of their transactions back to the mainnet.
Okay.
And so this data acts like a record, allowing anyone to reconstruct the state of the rollup and verify that everything has been processed honestly and correctly.
So they're outsourcing the work,
yes,
but they're keeping the security honest by reporting back to the main chain.
Exactly. It's like proof that they've done their job properly.
So this reporting back is currently costing the rollups a lot, though, right?
That's right.
That's the problem.
So right now, rollups primarily use something called call data on the Ethereum mainnet to store this essential transaction information. Now, call data is a standard part of Ethereum transactions. But it's an expensive resource.
Right.
Especially when you're dealing with the sheer volume of data that rollups need to post.
Right.
And this cost directly contributes to the gas fees that you see on mainnet.
Yeah.
And it wasn't really designed to handle these massive data uploads from rollups.
Right. So that's kind of where blob space comes in. This is the new, more efficient way for them to post the data.
Precisely.
A dedicated solution.
Yes. You can think of blob space as a brand new, separate data storage resource being added to Ethereum.
Okay.
It's like creating a dedicated highway lane.
I like that analogy.
Specifically for layer 2 data.
Yeah.
Allowing them to bypass
right.
the regular, more congested and more expensive call data roads.
So dedicated lane for roll-ups data.
Yes.
I like it. So how do these blobs actually interact with the regular Ethereum blocks that we're used to?
So imagine that regular Ethereum blocks continuing their job.
Yeah.
Of processing layer 1 transactions and smart contract interactions, as they always have.
Yeah.
Now picture these new blobs as almost like sidecars attached to these blocks.
I like it.
The main block itself will contain a small reference, essentially a digital address pointing to this much larger blob of data.
So the main chain just needs to know that the data exists in the sidecar?
Exactly.
Not necessarily like the details of everything in there.
That's right.
Just that it's there.
Yep.
Okay.
And so the layer 1 Ethereum nodes aren't executing the transactions inside these blobs.
Right.
Their primary responsibility is to make sure that the data in the blobs is available for a specific period of time.
Got it.
The actual processing and verification of that data happens entirely within the layer 2 rollup itself.
So interesting division of labor. Yeah. So how much information can one of these blobs actually hold?
Right. So each blob has a defined technical capacity.
Yeah.
It can store roughly 4096 field elements.
Okay.
With each element being just under 32 bytes in size.
Okay.
So we're talking about a significant amount of data in each blob.
Yeah.
Specifically designed to handle numerous rollup transactions.
Right.
And initially, the plan is for each Ethereum block to have the capacity to attach a target of 3 of these blobs.
3 blobs per block.
Yeah.
That sounds like much larger capacity for data than what we're working with.
Much larger.
But here's a question. How do Ethereum nodes ensure that all of that data in those sidecar blobs is actually there?
Right.
Without having to download every single blob?
Right.
Because that sounds like it could get out of hand pretty quickly.
That's right. That's where some really innovative cryptography comes into play.
Oh.
Specifically something called polynomial commitment schemes.
Polynomial commitment schemes.
Yes. These allow validators to probabilistically verify that the data within a blob is available through a process called data availability sampling, or DAS.
Data availability sampling.
Yeah.
Yes. Okay.
So instead of needing to download the entire massive blob, a validator can take a small number of random samples. And using the mathematical properties of these commitments, they can then be very confident that the rest of the data is also available.
So it's like checking a few random pages of a book.
Exactly.
To be pretty sure the whole book is there.
Yeah, that's a good analogy.
That's a clever trick.
And this is absolutely essential for keeping the hardware requirements.
Right.
For running an Ethereum validator at a reasonable level.
Right, because otherwise everyone would need a server farm to run a node, and that's not the goal.
Yeah, the goal is to keep it decentralized and accessible.
So you mentioned this being a step towards full Danksharding.
Yes. So EIP-4844 is the first phase, bringing in what's called Proto-Danksharding.
Proto-Danksharding.
Yeah, it implements many of the foundational technologies needed for full Danksharding. Like the new transaction type that carries these blobs, and the basic framework for ensuring data availability. So think of it as laying the groundwork for the full vision.
Laying the groundwork.
Yeah. Okay.
And this specific cryptography you mentioned, they're called KZG commitments.
KZG commitments.
Yes, that sounds
quite technical.
Very technical.
It is a bit under the hood, but you can think of KZG commitments as a very efficient type of cryptographic proof.
Okay.
Almost like a digital fingerprint, but with superpowers.
Okay.
And what makes them so powerful is their ability to allow someone to prove that a specific piece of data exists at a particular location within the much larger blob without needing to reveal the entire blob itself.
So it's like I can prove that page 32 of the book is there without showing you the whole book.
Exactly.
Got it.
And this efficiency is crucial for that data availability sampling we were just talking about.
Got it. So the validators can quickly get a yes, it's there, or no, it's not.
That's right.
Without having to see all the data.
Exactly.
Okay.
And you also mentioned something called Reed-Solomon code.
Yes.
What role does that play?
So Reed-Solomon encoding is another critical piece of this puzzle for ensuring data availability.
Okay.
So before the data from the rollup is put into a blob,
Yeah.
It's encoded using this mathematical technique.
Okay.
And what Reed-Solomon does is it adds a specific type of redundancy to the data.
Okay.
Think of it like adding extra information in a clever way.
Okay.
And this allows the network to reconstruct the entire original blob of data.
Okay.
Even if some portions of it become unavailable or are lost. Oh, that's cool.
It's like a backup.
Yeah.
Like a backup system.
So even if some of the data gets lost,
yes,
we can still reconstruct the whole thing.
You can still get the full picture.
That's cool.
Yeah. It's an extra layer of security and reliability.
I like it.
For the data.
Okay, so we have these large data blobs attached to blocks.
Yes.
Clever cryptography, ensuring that they're available.
Right.
Without overwhelming the network.
Yep.
And even a way to reconstruct the data if parts go missing.
That's right.
Now let's talk about like the part that really impacts us.
Yeah.
The cost.
It's the money.
You said this is going to make things cheaper for layer 2s and ultimately for me.
Yeah.
How does that economic shift happen?
So this is where things get really interesting for your wallet.
Okay.
EIP-4844 is introducing what's being called a two-dimensional fee market.
A two-dimensional fee market?
Yes.
What does that even mean?
So right now, the cost for rollups to post their transaction data on Ethereum using call data is all tied up with the general demand for transaction processing. The gas market on layer 1.
Right.
So if there's a sudden surge in activity on mainnet, say during a popular NFT launch, the cost for rollups to operate also spikes.
Right.
Even though they're primarily just using the network for data, not for complex computations on layer 1 itself.
It's like if there's rush hour on the main highway.
Exactly.
And even the side roads that are barely used suddenly get way more expensive.
That's a good analogy.
It's inefficient. Yeah.
So blob space changes this.
Okay.
It decouples these resources.
Okay.
It creates a separate marketplace. Specifically for data storage.
Got it.
With its own dynamics of supply and demand.
Okay.
And its own fee structure.
I like it.
This fee structure will likely operate similarly to the existing EIP 15509 mechanism.
Okay.
Used for regular gas fees.
Got it.
So the cost of using blob space will be determined by how much demand there is for blob space itself.
Right.
Rather than being dictated by the overall congestion on layer 1.
To its own separate market.
Its own market.
Dynamics.
Exactly.
And the expectation is that this new blob space market will be less expensive for rollups.
Yes. So the expectation is that, at least initially, the demand for this new blob space dedicated to rollup data will likely be lower than the current overall demand. That affects call data costs.
Right.
So this lower demand in a dedicated market should directly lead to significantly lower data costs for rollups.
Okay. Which means lower transaction fees for me when I'm using those rollups?
Precisely. With their underlying data costs reduced.
Yeah.
Rollups will be able to offer much more affordable transaction fees to their users.
Yes.
We're talking about the potential for fees to become so low.
Oh, wow.
They're practically negligible in many cases.
Near free transactions on layer 2.
Potentially.
That's awesome.
It's a game changer.
Now, as a regular user, could I just decide to use this blob space directly myself?
That's a good question.
If I wanted to store some data, like, is it open to everyone?
Yes, in the sense that the network won't prevent you from submitting a transaction that includes blobs.
No, okay.
However, it's specifically designed and optimized for the large amounts of data that rollups need to post.
Okay.
For an individual user wanting to store like a smaller piece of data, it would likely still be more economical to use regular Ethereum transaction call data.
Okay.
At least in the immediate future.
Got it.
The real cost benefits of blobs
Yeah.
are realized when you're dealing with the massive data volumes of layer 2 networks.
So probably not the new hot storage for, like, my vacation photos just yet.
Probably not.
You also mentioned that this blob data has a sort of expiry date on the consensus layer. That sounds a bit concerning. Like, my transaction history might vanish.
No need to worry about your transaction history disappearing on the rollups themselves.
Okay.
What we mean by expiry
yeah.
is the length of time that the Ethereum consensus layer,
okay,
the main network of validators, is guaranteed to keep the raw blob data readily available.
Okay.
And the current proposal is around an 18-day time frame.
18 days, why not keep it around longer?
Yeah. So the primary goal here
isn't
for the Ethereum blockchain to become a permanent universal data archive for everything.
Right.
The 18-day window is designed to be sufficiently long enough for layer 2 networks as well as other decentralized data storage solutions to reliably access and retrieve the blob data for their own longer-term needs.
Okay.
So rollups will have ample time to process the data, finalize their state, and potentially archive the raw glob data themselves, or through dedicated archival services.
So Ethereum is focused on the short-term availability.
Yes.
And then it's up to the layer 2s and other services to handle the long-term storage if needed.
Exactly.
Okay. That makes sense for keeping the main network efficient.
Yes, keeps things lean on layer 1.
So this all sounds like a big win for layer 2s.
Yes.
And their users.
Definitely.
But what about the other participants in the Ethereum ecosystem?
Yeah, good question.
How does this impact them? Let's start with the rollups themselves.
Yeah, so for rollups, this upgrade is a significant leap forward.
Okay.
The substantial reduction in their data costs directly translates to increased scalability.
Okay.
Meaning they can process more transactions for more users.
For more users?
And the potential to attract even more users by offering those much lower fees.
Right. Cheaper fees attract more users.
Exactly.
So they will need to update their underlying software and systems.
Yes, that's right.
To be able to utilize these new blob-carrying transactions.
That's right. They have some work to do.
Some upgrades, but it'll be worth it. What about the validators and stakers who are running the Ethereum network?
Right.
Well, they need to, invest in a lot more expensive hardware.
So with this initial Proto-Danksharding upgrade, the hardware requirements will see a modest increase.
Okay. Modest.
Modest.
Not a server farm.
Not a server farm.
Okay.
Current estimates suggest a need for around 50 gigabytes of additional storage.
50 gigabytes?
Yeah.
Okay, it's not too bad.
To handle the blob data temporarily.
Okay.
However, it's important to remember that this doesn't need to be permanent storage.
Right.
Due to the data expiry.
The expiry date.
Yeah.
Okay.
And the long-term vision of full Danksharding aims to further optimize this.
Okay.
And distribute the storage responsibilities even more effectively across the network.
So it'll get even more efficient in the future.
That's the goal.
Okay.
So while there's a small initial increase, it's designed to be manageable for the majority of validators.
Right.
And aligns with the ongoing goal of keeping node operation
accessible to anyone who wants to run a node. Exactly.
Okay.
Okay, cool.
And what about developers who are building decentralized applications?
Yeah. So
how do these cheaper layer 2 transaction fees affect what they can create?
So lower transaction fees on layer 2 will really open up the design space for developers.
Okay.
They'll be able to build more complex and user-friendly decentralized applications without being as heavily constrained by the high gas costs you see on layer 1.
Right.
So ideas that were previously impractical due to gas limitations on the mainnet become viable on these more scalable and affordable layer 2 environments.
Right. So it opens up so many possibilities for new apps.
Exactly. It's a whole new world.
Essentially, the layer 2s are taking this cheaper blob space
and offering it as their own much more affordable block space.
Exactly.
Okay, I like it.
For developers to build upon.
So they're reselling it, essentially.
Yeah, you could think of it that way.
Okay. And finally, the most important people.
Yes.
The end users.
Right. You and me.
That's you listening right now and me.
That's right.
We've touched on this, but can we summarize the core benefit for us once more?
Yes. So the most significant and direct benefit for you as an end user will be those substantially lower transaction fees on layer 2 networks.
Cheaper fees.
Cheaper fees.
Got it.
This will make using decentralized applications, transferring assets, and generally interacting with the Ethereum ecosystem much more accessible, affordable, and practical for everyday use.
Awesome. So EIP-4844 and blob space are a major step forward.
A big one.
But you mentioned full Danksharding is the ultimate goal.
That's right.
What's the big picture there?
So EIP-4844 is indeed the groundwork. Full Danksharding takes the core ideas introduced here. And expands on them.
Okay.
Especially in how data availability is ensured across the network. It aims to dramatically increase the amount of blob space available in the future.
Okay, even more blob space.
Even more blob space.
Okay.
By further distributing the responsibility of verifying data availability among a larger number of nodes.
Okay. And when might we expect to see full Danksharding?
That's a good question. It's still an active area of research and development.
Yeah.
But it's generally considered a longer-term objective.
Okay.
Likely a few years down the line.
Okay, so years, not months.
Yeah, years, not months.
Okay. And even further into the future, there's been talk of potentially enshrining a roll-up directly onto layer 1.
Right.
What does that even entail?
So that's a more advanced and still somewhat theoretical concept.
Okay.
The basic idea is that at some point, we might see a specific layer 2 roll-up become deeply integrated directly into the core Ethereum layer 1 protocol itself.
Okay, so like a layer 2 becoming layer 1.
In a way, yeah.
Okay.
And this could potentially lead to even more efficient scaling of layer 1 execution.
Got it.
By directly leveraging the advancements made with the roll-up-centric roadmap.
So taking all the best parts of layer 2.
Exactly.
And just putting it on layer 1.
Yeah, essentially merging them.
Okay, cool.
It's a sign that the journey of scaling Ethereum is a continuous process of innovation and evolution.
Always evolving.
Always.
Okay, let's wrap this up.
Okay.
So the key thing for you to remember is that this EIP-4844 introduces blob space.
That's right.
Which is a new, cheaper, and more efficient way for layer 2 rollups to store their transaction data on Ethereum.
Exactly.
This separation of data costs from mainnet gas fees should lead to much lower transaction fees.
Right.
For all of us who use those layer 2 networks.
That's the goal.
And this entire development is a critical part of Ethereum's overall strategy to scale through this roll-up focused approach.
Exactly. It demonstrates a clear commitment to making Ethereum more usable and accessible to a wider audience by harnessing the power and efficiency of these layer 2 solutions.
So what does all this mean for you? Well, think about it with transaction fees on layer 2s potentially plummeting. What completely new kinds of applications and use cases might become possible?
What crazy new ideas.
Things that are currently just too expensive to even consider might suddenly become a reality. There's a whole new landscape to explore within the growing world of layer 2 networks. Go take a look at what's being built. You might be surprised at the innovation that cheaper fees can unlock.
Absolutely.
Thanks for listening.
Thanks for having me.